All right. Hello, everybody. Welcome to this Vast Data webinar. Happy to be with you today. We are live on this Tuesday morning in the East Coast. But what we're here today is to discuss vast data sustainability and a report that we just put out recently, just a couple weeks ago, that outlines how VAST is taking a very innovative approach to sustainability and energy efficiency in the data center. I am here today with Howard Marks, and we have Boone White with us working behind the scenes to keep things running smoothly. Just normal housekeeping at the top. We do have a Zoom Q&A that's available for you to pop in some questions and comments as we go. We're going to keep the line open there, and we'll try to address everything toward the end of the session. So if you have any questions as we move through the slides, feel free to pop them in there. Lastly, and to go back to last Thursday, we do apologize. We are thankful that you're joining us again. We do have a special gift to sort of as a peace offering to you all. So be on the lookout for an email coming from Boone and our team at the end of this webinar, and you will be able to be in line for a special gift straight from Vast Data as a token of our apologies. So so without further ado, we'll hop into it. I'm Jim Crook, and it's great to be here with Howard Marks, longtime veteran of storage. And today he serves as VAST's technologist extraordinary and plenipotentiary. Good morning, Howard. How are you?
Good morning, Jim. I'm just ducky this morning.
Excellent. Okay, so why are we here today? Why did we write this book? I think, we don't really need to explain, the mandate or the focus around green and energy efficiency in today's enterprise. I think many of you on this call, if not all of you, are sensing that in your own businesses. But just to frame it from a high level perspective and what our industry analysts are saying, in the middle of 2021, a survey of Gartner's senior business executives said that environmental sustainability is a top 10 priority for the business. Gartner earlier this year put out a report saying that 80% of enterprises with sustainability strategies will include infrastructure, ops, and cloud as a top priority for their investment by 2024. And then just a couple months ago, Eric Bergener at IDC put out a report that stated that power efficiency will be a top 5 criteria for purchase decisions within the next 2 to 3 years. So we're feeling this this trend towards sustainability as a business priority. Sure, many of you are seeing that in your own organizations, and especially with just the overall current energy climate situation in the world today, where things are getting more and more challenging. So that's why we're here, and that's why we've unveiled this new sustainability report. You can read it today. You can download it at vastdata.com/sustainability. We're not going to go through the entire report today, but what we want to do is go through what we think are some of the key points, and that'll help you understand VAST's approach to this topic. We're going to talk today about the limits of hard drives and why this media is falling short in terms of what it can do for energy efficiency. We're going to talk about how VAST's new architecture, new approach called DAYS, is unlocking new efficiencies in the data center. We're going to talk about how VAST is working to reduce carbon emissions and e-waste. And then we're going to provide some context. We're going to take a look at some comparative examples, some other vendors you might see in the marketplace today, and explain how we compare against them. And as I mentioned, we'll have the Q&A open, so please feel free to put some questions in. We'll try to get to all of them by the end of this session today. But Howard, I'm going to hand it over to you now, and we're going to talk through, trying to get a better understanding of why flash versus hard drives in the data center. What are the consequences of each, and what are some of the key innovations in VAST Universal Storage from an energy perspective?
Well, it's been clear for quite a while that flash-based systems use less power than the high-performance disk systems of days gone by. But even if we look at the densest example of both a hard drive and an SSD, SSDs have a substantial advantage, not just in power density per terabyte, and especially in power density per IOP, but also in physical density. You know, the SSDs that we're shipping today hold 30 terabytes, the largest hard drives barely 20, maybe 24 if we listen to the hard drive vendors. But that SSD is in the 2.5 inch, not the 3.5 inch form factor. So there's a substantial space savings as well. But flash alone is just the beginning of the efficiency story. And as we'll see on the next slide, the vast efficiency story, advance a slide, there you go. The vast efficiency story starts with using the largest SSDs we can to minimize the power consumed by SSDs, because one thing people forget is that an SSD or a hard drive draws roughly the same amount of power regardless of its capacity. The other thing about SSDs is that they simply fail less often. Our friends at Backblaze published some data on this recently. Boone just posted a link in the chat to that. But just using 30 terabyte SSDs is one step in the path to getting the most efficient storage system. The next thing we have to do is use efficient methods for managing that flash, high efficiency data reduction, high efficiency erasure codes for data protection. And power isn't the only consideration. E-waste is a big consideration as well. Electronics contain nasty elements and things like rare earth and hard drive magnets or tantalum in capacitors that have environmental impact in their creation. And so reducing e-waste is significant. And we do that in part by using less hardware in the first place, but more significantly by babying those SSDs and managing the flash endurance so that our customers can continue to run the same SSD for 10 years as opposed to the industry standard 5. And that means vast customers need to replace their hardware half as often and create substantially less waste. And then the part that people don't realize that actually can have the biggest impact is by having an all-flash system with higher performance, your compute nodes in your data center spend less time waiting for storage, and therefore you can complete your compute tasks with less CPU and draw less power from the servers. And that can significantly be larger than the amount of power you save on storage alone. But Jim will talk about that in just a minute.
That's right. Thanks, Howard. Right. So, all of those innovations that Howard just went through, they compound and they combine into really interesting savings in terms of both carbon emissions, energy costs, and we'll walk through some of those other metrics. But as an exercise in writing this report, we wanted to help customers understand what those radical differences can be from those innovations that Howard just went through. And so in this slide, what we take a look at is if a customer were using a legacy system, maybe 4 or 5 years old, and they made a switch to VAST, replacing a hybrid storage system. In this comparison, we use a Dell PowerScale H500 with 4 terabyte hard drives. We just wanted to give a cost or a comparison around what does that mean in terms of carbon emission saves. We got out our calculators, got our pencils, did a little math. We realized that we can potentially save customers in a 5 petabyte configuration, and as we go through this report, you'll see we mostly stick to 5 petabyte configurations just to keep it apples to apples. But in a 5 petabyte configuration, we can save customers up to 400,000, or on average, or around 400,000 kilowatt hours per year. And when you take that 400,000 kilowatt hours and you pop it into an EPA calculator that you can find on EPA.gov, you can do a lot of fun things on that website, as we'll talk about. We find that you can that 400,000 kilowatt hours translates into 283 metric tons of carbon emissions saved per year. And so when you think about what 283 metric tons of carbon emissions saves actually represents, it's hard to get your head around that. What we're enabling is actually a reduction in pounds of coal burned, or it's equivalent to 313,000 of fewer pounds of coal burned, and 655 fewer barrels of oil consumed. And you can add as many examples here as you want. Number of phones saved, recycled, energy spent on winter heating and things like that. So just understand that this number 283 metric tons has some real life consequences that can be applied when you're making a change from a legacy hybrid system to an all flash highly efficient system like VAST. And then it's not what we lead with from an environmental perspective, because we're focused here on sustainability and doing right for the environment, but from an energy cost savings, an energy bill that your organization is paying year over year, there are really significant benefits to VAST as well. And we're using the same example here, the same comparative system and a 5 petabyte cluster. What we found is that your costs go up with the legacy system. Your costs with VAST, as you can see in the green line here, relatively flat. And so with that hybrid system, you're paying upwards of $500,000 over 10 years. With VAST, you're paying about 90% less. We're basing these numbers on the average electricity price for business in the US, so your mileage may vary. But that's how we got to those calculations. And and Howard, as we just saw yesterday from the US government predicting soaring electric bills this winter, that these numbers may be getting even
yeah, I was just going to point out that all of these numbers assume a constant cost of power, and that's not really predictable, especially in Europe, where the difficulties in Ukraine are leading to shortages of natural gas for them to generate electricity.
Exactly right. I think you can look at the European countries on this slide here, especially, and see the amount of cost savings that a VAST system can provide versus a legacy hybrid system. As you mentioned, Howard, it's a 90% constant cost savings worldwide, but those numbers do ebb and flow depending on where you are. So, and by the way, we got these numbers as of December of 2021. So 10 months ago, we can probably guess that they're skewing either farther to the right. But this is what it looks like from a global perspective in terms of energy cost savings. And so Howard, my first impression of VAST, and coming to understand and really appreciate the VAST days architecture, which you're going to walk us through, is really around the benefits of scalability and performance that we're providing customers. But from working with you on this book, what I've really come to appreciate is the energy efficiency angle as a natural byproduct of that system and that new architecture. So in this next slide, Howard, maybe you could take us all through how days disaggregated and shared everything is really a foundation for green data centers and building a bridge to new levels of energy efficiency in the data center.
Well, it's not just, and in fact, it's not primarily energy efficiency, it's just efficiency. And VAST systems are really the first all-flash systems designed with efficiency as the primary goal. Previous all-flash systems were designed to provide a lot of performance from a small amount of flash to be that tier 1 in the traditional pyramid. VAST was designed to break that pyramid by making flash affordable enough and that's affordable enough to purchase and affordable enough to operate, but to make flash affordable enough that you can stop using spinning disks altogether and use flash for all of your workloads. And that meant we were going to have a large amount of data. And knowing that we were building systems that had hundreds of SSDs, we had a lot of performance available and we could concentrate on efficiency, knowing that performance was going to come along because it was an all-flash system. And so in terms of the overall architecture, that is displayed in the fact that we've separated or disaggregated the compute function of the storage system, the managing the erasure codes, the managing where a particular file or object is and such, is everything you'd think of as the controller function in a storage system, in a series of stateless servers that you see roughly in the middle on the diagram. And then we've put all of the capacity, both the actual storage capacity and the SCM capacity to hold metadata and other things, in HA enclosures, and we allow you to scale them independently. Well, that means that for a lot of the applications that we're talking about, where users are making the transition from hard drives to all flash, they don't need all the performance that the SSDs could deliver. They need somewhat better performance than they have been getting from hard drives. And so we can scale the compute servers to provide that level of performance using fewer compute servers than if we were in a more performance-oriented application, and therefore drawing less power. And we frequently do this in places like backup targets, where we're aiming to deliver slightly better performance than the disk-based system that they're replacing, because if we were much faster, the media servers and data movers and other parts of the backup infrastructure couldn't keep up. And so it would be wasted performance. Rather than buying a fixed amount of compute for any given amount of SSD and wasting the performance, we let customers vary that. On the next slide, you can see the 3 main pillars of our efficiency. The first is to baby the flash, and we do that by very carefully deciding where data goes, predictively placing data so that we will minimize the amount of movement of data on the SSDs and therefore the SSD wear. The second big thing we do is data protection through locally decodable codes that lets us have a very high level of data protection, N+4, so we can lose 4 SSDs without losing data, but with very wide stripes so that we have a very low level of overhead, under 3%. And then finally, data reduction has been key to making flash affordable, but we keep pushing the envelope on data reduction technology, adding things like similarity that reduces the amount of capacity that needs to be stored when 2 blocks are not identical and can't be deduplicated, but do have a lot of common data within them, and data-aware compression techniques that are very specifically designed for things like numerical data from instruments. So overall, the vast story is about efficiency.
That's right. Thanks, Howard. Yeah, thanks for that overview, Howard, about how DAYS is laying the foundation for us to really run these algorithms around flash to drive a lot of new efficiencies. And what Howard also mentioned at the top of this webinar was around how we're enabling compute and how compute enables a much better efficiency standpoint for the data center from an energy perspective as well. And so let's talk here on this slide about a little bit about how we're enabling computational efficiency. Overall, in a data center, compute it makes up about 80%, give or take, of a power expenditure in a data center. So it's so that's worth repeating. Compute is 80% of everything that happens in the data center. So if you can bring down the amount of power consumption on the compute layer, you're going to really bring down your overall power consumption comparatively against storage and networking as well. So VAST is working with a lot of customers today that have very large HPC environments. And as that name HPC suggests, compute is a massive part of what they do every day. And when they're able to move to SSDs and away from hard drives, they're able to drive a lot more power savings at the compute level. And maybe we put it another way, if your servers aren't waiting as long for data from a hard drive based storage as they are from an all flash based storage, you can run jobs on fewer servers. And when you can turn off a certain percentage of your servers and still have the same performance that you did beforehand, before VAS and all flash system, you're going to be saving a significant amount of power, again, because compute is taking up so much of the power expenditure in a data center. So this slide talks through that a little bit. And these are three customer examples, VAST customer examples of that point. First one is with NOAA. And NOAA actually got on stage at the 2022 HPC forum and talked about how VAST today is reducing the amount of power from their post-processing compute infrastructure by about 50%, and that's with VAST. Invitae is another organization that is talking about taking their workflow test runs that were initially going from 24 hours, and now they're moving to about 15 minutes with VAST. And then NIH, the National Institutes of Health, they are reducing their power by about 25%, and that's come directly from reducing the 25% of the servers they need to run their jobs. So getting back to that, what we were talking about before, NIH is essentially cutting out 25% of the servers because they don't need it anymore to run as fast as they were with before VAST. And when they can cut out that 25% of servers, they reduce their power by 25%. And that number can be really significant, especially in big HPC environments where they're running often thousands of servers. So it's not insignificant at all. And in the press release, we also had the National Renewable Energy Laboratory, NREL. They're another customer of VAST that's also benefiting from a lot of the compute efficiency gains that VAST is providing. And if you think about that, just from this sort of waterfall chart perspective, we wanted to show what it looks like when a customer is deploying on VAST, and what their expenditures in terms of wattage for each layer of the overall VAST architecture, and what that means for their power consumption. So in this slide, you can see here, again, we're sticking with that 5 petabyte configuration. The raw power cost of those 5 petabytes, you can see it's a little under 20,000 watts. Howard mentioned how we're really enabling the most efficient levels of data protection overhead, 2.7%. And so that adds a very minimal layer of wattage on top of that raw power cost. But then where we come in is where Howard also talked about the data reduction. And when we can reduce the amount of data that's in a cluster through these advanced reduction techniques, theoretically, we're shrinking the amount of enclosures and capacity that's actually needed. Therefore, we're bringing down that wattage significantly. And on average, we're reducing data by about 66%. And then again, the power savings that come from the compute layer are really impressive. And it's 20, let's say we're saving 25%, as in the NIH example, of compute power savings, that is a massive amount of power saved because of the overall amount of compute that's driving power expenditures in a data center today. So drop your compute power by 25%, you're dropping your overall power consumption very significantly. And that's why we come to this conclusion toward the end of this report that an all-flash VAST DAYS system essentially pays for itself just in compute power savings compared to a legacy hard drive system. So that's a really powerful takeaway from this report that we found. It's especially on the compute layers is really where VAST is driving very significant efficiency and power savings. You know, the other part of this is e-waste. Howard mentioned at the top how we're helping to reduce e-waste. The biggest way that we're doing that is by eliminating the refresh cycle. So today it's and for decades in the storage industry, vendors in the space have operated by selling a system and then upgrading after a few years, after 5 years, and at that point the customer needs to buy a new system, refresh, get the old system out of there, and that's been happening for a long time, as I'm sure Howard could talk about. But with VAST, what we were enabling is a 10-year guarantee on all of your hardware, on all of your infrastructure, so such that you don't need to replace and refresh your infrastructure every 5 years, every 4 years, every 6 years, whatever it is. And when you don't need to refresh your infrastructure on a regular cadence, you can keep that infrastructure living and or operating your system, and you don't need to bring in anything new, which means you don't need to recycle. You don't need to send any e-waste out into the landfills or however these or to be recycled. Overall, e-waste is a significant challenge. According to the UN Global E-Waste Monitor, it's one of the fastest growing waste streams around the world, and it's expected to surpass, and we have this in the press release, 74 megatons by 2030. And so if as an organization, as VAST, we can help customers completely eliminate the need for refreshes and completely eliminate the need to send old hardware out into some sort of e-waste stream or recycling stream, then we're proud to help do that. And this is a bit of a comparative example as well. You see how we compare against a hybrid power scale system, how we compare against an all-flash FlashBlade with Pure Storage and their evergreen subscription service where customers can replace controllers every few years on more of a more rapid cadence than previously before. And you see how VAST is coming in at the same the amount of weight of the system that goes into the system on day one is the amount of e-waste you have in your data center at the end of 10 years. And that's another powerful example of how universal storage is really rewriting the playbook in terms of data center overall efficiency, and in this case, e-waste. We have we've had a couple of customer references in this book, and the University of Auckland also provided us a quote in our press release a couple weeks ago. University of Auckland is actually well known for their efforts in energy efficiency and green awareness, and they put a lot of efforts toward their sustainability agenda, and VAST is proud to play a very key role in helping them move towards their sustainability goals. All right, Howard. So let's dig into as we sort of round up this webinar. Let's dig into just a few comparative examples where we looked at some other vendors that customers might see in this space.
The first example is a comparison to a Dell EMC Isilon cluster, what they now call PowerScale. This is using their hybrid class nodes with the 8 terabyte hard drives that they sell to most customers looking for a system that can do sequential I/O well, but is without really any random I/O performance. And as you can see, the VAST system, because we're using substantially larger SSDs in denser enclosures and separating compute from capacity, we managed to deliver the same effective capacity from less raw capacity through both more efficient erasure codes and data reduction, and do that consuming substantially less power, about a fourth as much, and substantially less rack space. On the next slide, we have a similar comparison against PowerScale, but in this case, using their higher density all flash nodes. And we still have about a 46% power advantage, 43% power advantage, and about a 2-to-1 advantage in terms of e-waste. Not to mention that the VAST system delivers just a little bit more performance for that lower capacity, lower cost, and lower rack space, lower cost, and lower power consumption. And then finally, if we compare ourselves to another vendor who specializes in all flash systems, Pure Storage's FlashBlade, again, we get substantially less power, substantially less space, and somewhat higher performance, all because we've been designed from the beginning to be more efficient. And that's really it for the comparisons.
Great. Yeah, folks, we've got additional comparisons in the book, so you can download that and check it out. Again, that's at vastdata.com/sustainability. Okay, so Howard, we're gonna wrap it up. This is the summary of what we talked about today. We really think that based on the innovations in Flash in the VAST architecture days, that we're able to offer the ultimate in efficiency for a greener tomorrow in the data center, and that's from a power perspective, that's from an e-waste perspective, that's from a compute efficiency optimization perspective as well. And we're so confident, maybe not the right word, but we're really, you know, happy to talk about this with you, and we're happy to show off how this will compare against other vendors in this space. And so we guarantee it. We're putting some skin in the game on this, and we want you to really take a close look at the VAST system, compare it to others that you're looking at, or other systems that you have in your data center today. And if a VAST cluster consumes more power than any other comparable storage system in any sort of comparable configuration, we'll pay the difference in carbon credits, and we'll be happy to do that. So either way, we really want you to be confident that you're making the best decision from an energy perspective and a sustainability perspective for your organization in your data center. And so that's the VAST guarantee here, and you can reach out to us if you have any questions on that, and we'd be happy to work with you on that. Okay, so we've gotten through the deck here. Howard and I are going to take any questions that may have popped up. You can still throw them into the chat, and we'll see what we have here. Let's see if I can find them here, Mr. Boone White.
Well, I see one question about how we calculated power consumption. And we used the manufacturer's typical power consumption. The nameplate on a piece of equipment typically has the maximum power that equipment can consume, but that's not how much power the system actually does consume. With spinning disks, it's frequently the amount of power it draws for the first 2 minutes as all the disks spin up and use a lot more power doing that. It's not really relevant to energy consumption, so we use typical. VAST systems have an additional technique we use. It turns out most of the power in an SSD is consumed when you write, not when you read. And so we have a method of predicting and throttling the system to meet specific power requirements, but that's more about fitting in a maximum power rack in a data center than about energy consumption, because doing the same amount of work, the system would use about the same amount of energy.
Great. And then we've got another question here, Howard. I think you tapped into this a little bit when you're going through the flash efficiencies with universal storage, but what's the secret sauce behind a 10-year guarantee? What does that look like? How do we enable 10 years
Okay,
of infrastructure?
So there's a couple of things. First of all, guarantee is a bit of an oversimplification. What we guarantee is that we'll write a support contract for any given piece of hardware, including replacement of failed devices, for 10 years from its date of installation. And there's no exception in that for SSD wear out. And so the real key to the 10-year, to our being able to write support agreements for 10 years is the way we treat the SSDs. You know, we write data to the SSDs, we manage how data is placed on the SSDs. We use a variety of techniques to minimize the amount of wear on the flash itself. We don't treat SSDs like fast hard drives and black boxes. We understand how they work internally, and we align our data with their internal structures to maximize the endurance of those drives. And we're so confident in that if a drive wears out 7, 8, or 9 years after installation, we'll replace it as part of the support contract.
Excellent. Well, thank you, Howard. Okay, well, I think that's all we've got for today. We want to thank everyone for joining. We were happy to present this topic. It's really important. We want to make sure that you are in the best position to make the best decisions for your data center. And so if we can help you with that in any way, please reach out. We will share this deck. We'll share the webinar recording by email shortly. So be on the lookout for that. Be on the lookout for the special link in that email with a gift for you for joining and putting up with our technical difficulties. Okay,
we did get another question.
Oh, we got one. Okay.
When you quote less time for compute, is that keeping all things equal with the same servers, only changing out the storage? Yes. That assumption is for a fixed amount of compute with new storage. Generally in HPC centers, as opposed to corporate IT where you run virtualization, the compute nodes are busy all of the time. And so that's assuming that these SSDs that these CPUs were busy.
Follow-up question on that one, Howard.
It's not, so the question is how much CPU does it cost for servers to be waiting on storage IO? It's not so much that CPU utilization as that CPU being idle. And so an HPC center can submit a job to do, the simulation of a nuclear explosion. And that runs on some 1,000 servers for some set of days. And the number of days to run the job would be reduced. So you could either use less servers to run that same job in the same amount of clock time, or run more jobs. And we've calculated the power based on, we have 22 days to run this job, and we could do it with 800 servers instead of 1,000 servers.
All right.
I think that's it.
Looks like you've answered it all, Howard. So thanks again, everyone, for joining, and have a great rest of your Tuesday. Bye-bye. Thanks, Howard.
Bye.